So I'm just going to re-audio this video, okay? So what we have is we have a car has an initial speed of 4 of u ms minus 1. It moves at a straight line with constant velocity acceleration f for 4 seconds. It travels 40 meters while accelerating. That explains why a plus b equals 40. Okay? It travels 40 meters while accelerating. The car then moves with uniform speed and travels 45 meters in 3 seconds. Basically means the area of the rectangle, which is v in height and 3 seconds across, is equal to 45. So 3v equals 45, and phi will have to equal 15. Okay, so that should be 3v equals 45 and v equals 15 for that. Okay, so next thing we get is we have a. So once again, lads, this should read v equals 15, not 3v equals 15, right? Because of 3v equals 45. Now, we have a triangle A and rectangle B. Rectangle B is u in height, 4 seconds across. It's 15, take away u for the blue height. That's why it's a half 4 times 15 minus u, okay? And then we get 4u plus, it's basically half of 4 is 2. 2 times 15 minus u, 30 minus 2u. Okay, wow, this is fast. Let's go for 0.5. Okay, so 2u plus 30 equals 40. Because remember, the area of A and triangle A and rectangle B is 40. This should yield 2u equals 10 and u equals 5. So now we know that phi equals 15 and u equals 5. Okay, in regards to total distance traveled, we have to find out it's brought to the last section. There's a deceleration of 2f. So we find out what the acceleration of f is in the initial phase. We should be able to find out what 2f is then. Okay, so here's what we're going to do. We're going to have 15 and 5, which is a height of 10. Tan x will give us the acceleration. Tan x is going to be 10 over 4, which is f, 10 over 4. And then we're going to get f equals 2.5 or 5 over 2. So that means 5 over 2 is the acceleration. Now we got to do the deceleration. Okay, so the deceleration is 2f, so it's going to be 2 times 5 over 2, and that means the deceleration is minus 5. So now we have enough information about the final triangle, or the deceleration period. We know that it starts off at the red dot, the u value is 15, accelerates down to rest, that'll be a phi value of 0, a value of 5, and an a value of 5, minus 5, and an s value of, we don't know, that's the point of the question, okay? So we're going to do our UVAS formula here. I think we can use v squared equals u squared plus 2as. And what we can do is we can find out the s value. So v is 0 squared plus 15 squared plus 2 times, 2a is minus 5. So 2 times minus 5 is minus 10, minus 10s. 15 squared is going to be 10s equals 15 squared, which is 225. S equals 22.5. Now that's the distance you spent in the deceleration zone. Okay. You also got to add on the 40 and 45 meters to get your answer. Okay. So 40 and 45 meters. It's going to be 40 plus 45, and then you're going to add on your 22.5 as well. You get 107.5 meters. Okay. Now, question 2. Particles projected vertically upwards with a velocity of u meters per second. After an interval of 2t seconds, the second particle is projected vertically upwards from the same point with the same initial velocity. Imagine a red particle that's on its way up. Okay, and then later on, the blue particle is thrown up after it. Okay, now what can happen is the collision can happen usually in 3 ways. If the blue particle was faster than the red particle, the blue particle could hit it while the red particle is still on its way up. If the blue particle was much faster, or the red particle could be just stopping and the blue particle would strike it at that instance. That'd be very rare, not going to happen. The third scenario is that the red particle is on its way down, the blue particle is on its way up, and the blue particle therefore collides with the red particle. Okay? And that's what we're suggesting will happen here. The red particle will be on its way down, and the blue particle will be on the way up, and the blue particle will hit the red particle. Okay, so like that. Right, grand. Now, let's move on from this. We're going to need two sets of UVAS. We're going to need a UVAS for the initial particle and a UVAS for the second particle. Okay, so that's UVST for the first one, UVAST for the second one. They both have a common velocity of U meters per second. Now, they collide at the same height. And please remember it's displacement. S means displacement. So they collide at the same height. So that means their S values are going to be the same. Okay. Now, what I basically explain here is that the difference between displacement and distance, if you go 40 meters up, 20 meters down, you've covered 60 meters. But yet your displacement is 20 meters where you started from. So please be aware that S means displacement. It does not mean distance covered. Okay? Key point. They both hit each other at the same point. The red stone will travel further than the blue stone. Okay? Because the red stone will go up and back down again. There are two potential systems you could use. You could use time spent in the air by the redstone, which is thrown first and therefore spends more time in the air, is T1 plus 2T. And then you could say that the blue particle spends T1 in the air. That's one possible system. Another possible system is to say that the red particle spends T1 times in T1 seconds in the air, and the blue particle spends T1 minus 2T in the air. I'm going to use the T1 minus 2T system, just the marking scheme matched it, so it's to use the same system. Both systems work. Okay, so don't be worried either way about stuff like that. Okay. Now, we're going to do a bit more filling out. The U value is going to be the same for both of them. So the U value should be U for both of them, okay? So U should be U for both of them. Okay, U. Acceleration is minus gravity for both of them because both of them are working against gravity. Okay, so both of them are working against gravity, like so. Now, what should happen next is we're going to use S equals ut plus a half at squared because we don't know much about the final velocities there. We're missing that. But we know that S1 equals S2. The displacements are the same upon collision, okay? So we're just going to do a bit of algebra for the S1 and S2 scenario here, okay? So you can see H there. I'll just move this slightly to the left. H equals ut1 plus a half gt2. That's using ut plus a half at squared. The next one is u times t1 minus 2t minus a half gt minus t2 squared. So we're using, remember, ut plus a half at squared for both data sets. Now, you're going to have to multiply all of this out. I'll let you guys look at the algebra yourself. You're just squaring out that t1 minus 2t squared. Right? Then you multiply it out to ut minus hut minus a half g t squared, and you basically get all these numbers here. Okay, so far we're good. Now, what's going to happen next is we know that the two of them have to be the same. Don't mind that. It's not those two. It's actually the one further up. So if we pause here, the two yellow equations have to be the same because the height of the red particle, the displacement of the red particle equals the displacement of the blue particle upon collisions. So what basically happens next is that the ut1 minus a half gt1 t squared equals the other equation. The two yellow equations equal each other. What should happen is they both cancel. A lot of stuff cancels on both sides. There you go. What we're going to do is we're going to isolate t1. No t1 in our answer. Look at the top. H equals u squared minus g squared t squared over 2g. There's no sign of t1. So what we're going to do is we're going to isolate t1 where we can. So what should happen here is that we isolate t1. Okay, so 2ut minus a half 2gt squared equals 2g t1. Okay, so I moved the two of them to the left and left the 2g t1 on the other side. Now, what we're going to do is we're going to cross out the t's, and then we're going to cross out the 2's. Okay, and then what we should get next is we should get t1 equals u over gt all over g. Now, that's the way the answer is for the T1. Some people might draw it slightly differently. They might divide in by the G, but there's really no need. I don't imagine there'd be any significant gain from doing it that way. Now, there was a mistake here. It was actually a plus. It should be a plus 2gt squared. We move the gt squared from the right to the left. So that should be plus gt. Okay. Now, what should happen here next is that basically some people can divide in by the g if you want, but I don't see that being a significant technique. Now, the one thing you're going to know about your question is that it has h in the answer. So it means we should reuse the equation h equals ut1 minus a half gt1 squared, and this will help us to get h, get rid of t1 like we wanted. So here it is here. So you're going to see it all multiplied out, u over gt over g, u plus gt over g, and then we multiply it out, u squared plus ut over g minus a half g. Now we've got to square that out to get u squared plus 2gt plus t squared over g squared. The g cancels top and bottom. Now there's going to be a denominator of 2g on the second part, so if I make the first part 2g as well, that'll help me have a common denominator. So it's going to be 2g, I'm multiplying top and bottom by 2 there. And then on this side, I'm multiplying in by the minus. Now, I made a mistake here. See here? That should be g squared t squared. See where my pointer is? You'll see me fix that in a minute or two. So it should be g squared t squared, okay? So what should happen is they all cancel out here. The 2 down cancel. We have u squared minus t squared over 2g. I look back at the answer, realize I was missing a g squared. Where to spot it? Isan showed me where to find it. That it comes from here. When you square this out, the gt, you should be able to find it here. There's the gt, forgot all about it. So it should be g squared t squared. Foolish me just put in g, but it should be g squared t squared. So put the squared in there. And finally, that is your video done and dusted, right? So that is linear 2016 redone in 12 minutes.